Hi guys, and welcome to today's video on the inverse matrix. It's a continuation of our matrices series. We've looked at adding, subtracting, multiplying them, multiplying by scalars. We still haven't got to that point of being able to divide them because I keep telling you we can't divide matrices. Although we can use a bit of a funky trick that's coming up in our next video. But let's build the basics. Let's work out the groundwork first, and we'll work out this thing called this inverse matrix. Now, what am I going to do? I'm actually going to go straight in and show you how to do the inverse of a matrix. It looks confusing, don't get me wrong. But when I basically explain that it's about corners and numbers in our original matrix, life is going to be just so awesome. All right, so let's first off say that generally to find the inverse of a matrix, we have to know what the original matrix is. And we give it letters. So everywhere there's a number, we're going to say A, B, C, and D. This is just at this moment in time to show you how the process works. So if we have a matrix A, B, C, D, where these will actually be numbers, and we'll call this matrix A, the first thing to notice is our notation. The inverse is shown by that floaty -1. Easy. Then we have this one on AD minus BC business. And what's that all about? Well, this bottom section is actually called the determinant. We'll come back to that in just a moment. But all you need to do is you take opposite corners of your matrix and multiply them together. These two corners of your matrix, multiply them together, and then subtract the result. Why? Well, later on it actually helps us work out whether an inverse can or cannot be taken, right? Because not all matrices will have an inverse. I'll show you why in a moment. So that's that section. What's the next section? Well, what it then says is that we take the values of A and D and we simply swap them over. So we put the value of D there and the value of A there, right? At the moment, this is like a process. It's like baking a cake. Follow the process and the inverses are going to be really easy. And then we have minus B and minus C. Now, what that means is multiply the values of B and C by -1. Alternatively, just change it from positive to negative or negative to positive, right? The process sounds confusing. Let's do a few examples. So here we go. We've got A equals 2, 2, 3, and 4. All right, so A to the -1, if we remember, is equal to 1 on AD minus BC. So if we compare that, we've got A, B, C, and D. That means AD, so we do 2 times 4, which is 8, minus 2 times 3, which is 6. Opposite corners, multiply them, opposite corners, multiply them, and subtract them. Okay, so we've got the AD, we got that. Then we multiply that by our, so this is where we do the funky swapping. So the value of A and D swap, so the 2 and the 4 swap places. That's that done. And then the B and the C, so there's a 2 and there's a 3. If it's positive, turn it negative. If it's positive, turn it negative. And there we go. So that, ladies and gentlemen, is the start. We've just got to finish this off. So that becomes 1 on 8 minus 6 is 2 of 4 minus 2 minus 3, 2. And again, going back to our previous video on multiplying by scalars, we now realize that every value inside has to be multiplied by a half. Or we're just going to take a half of each of those values. So that becomes equal to a half of 4 is 2. A half of -2 is -1. A half of 3 is -3 on 2. And a half of 2 is 1. And lo and behold, there is my inverse matrix. Now we're going to use this later on in different videos, but the process of inversing is freaking awesome. A is equal to 2, 3, 2, 3. Okay, so finding the inverse of this matrix, A to the -1 is equal to, right, 1 on. So AD minus BC. So AD is 2 times 3, which is 6. Minus B times C is also 6. Hold on a moment. You see a bit of a problem there. Okay, I'm going to do my brackets. What do we do now? We swap the 3 and the 2 over. That becomes -3, and that becomes 2. Now, finishing this off, we give us 1 on 0, and uh-oh, there is a problem. Now, I cannot do 1 divided by 0. It's one of the things that we'll be taught since junior school, and dividing by 0 means that basically this thing here is going to be completely undefined. What does that mean? It's just not possible. So if this section here isn't possible, then there's no multiplication, and so that there is also not possible. And it's basically said it is undefined. It basically means, in a shortcut, that whenever the value underneath here is a 0, that we cannot find the inverse of a particular matrix. So in this situation, we could not find the inverse of that matrix there. We can use our CAS calculator to find the inverse of a matrix nice and easily. How? Well, much like we've done before. Define your matrix here, and then let's store it in a value. When I hit execute on my Casio CASPad, then out comes 2, 2, 3, 4. Thank you very much. How do we then do the inverse? We just tell our calculator, we'll take my value of A and raise it to the power of -1. Now, CAS speak, that needs the little caret, which basically is nothing more than raising to the power. And out comes the fabulous value of 2 minus 1, minus 3 on 2, minus 1, which is what we got earlier. Love it when the calculator agrees with me. It means I've done it right. Now, I keep going on about this determinant of a matrix, right? This bottom thing. Previously, it was 0. That was bad. We didn't like 0. We like any other number, but not 0. What is the determinant? Well, it's just a way of telling me whether an inverse is possible. So the determinant of a matrix is given by AD minus BC. A lot of people think it's the fraction in front. It isn't. It's the bottom of that function. It's the value of AD minus BC. And believe it or not, your CAS can work it out for you as well. How? Well, you just type DET. Carrying on from my previous example, having already defined my matrix, I can just actually type DET. There's probably a function on there as well. Open brackets A, and out comes that stunning value of 2, which is what we were expecting previously. If we scroll back up, then what we found was the bottom of that original fraction was 2, and that is my determinant. Let's do a couple of examples where we're finding determinants of various matrices. There we go. A is equal to that. So the determinant of capital A is given by, so 2 times 5 minus 3 times 3. Again, opposite corners, 2 times 5 minus 3 times 3. 2 times 5 is 10, 3 times 3 is 9. And so in which case my determinant there is 1. That means there is an inverse. I is a happy bunny. We've already seen this example, but we're going to do it now. So determinant of B is equal to opposite corners 2 times 3 minus 2 times 3, 6 minus 6, which equals 0. So in that situation, I would know there was no inverse. Finally, determinant of C gives me 2 times 3 minus 2 times 4, and that gives me 6 minus 8, which equals minus 2. Good news, ladies and gentlemen, we can have negative values. The only one we don't like is 0. How did this help us divide matrices? I told you we're coming to it now. What I wanted you to do was know that actually there is something pretty funky that happens when you multiply a matrix by its inverse. So following on from my previous example, if you remember, I defined my matrix as A. Calculator said, all right, there's A. I did my inverse, which gave me this. So what I now wanted to do was go back and say, well, what happens when I multiply A by its inverse? So take A and multiply it by A to the power of minus 1. And what you end up with is 1, 0, 0, 1. Which, if you've watched my previous video, you'll go, hold on a moment, Darren, that's the identity matrix. It is, I know, how exciting. I changed the example and I wanted to see, was it only that matrix that it happened to? So I now redefined A and I worked out its inverse and I worked out, and hold on a moment, what do you notice? Out comes the identity matrix. And I thought, no, it must be a fluke. I've just chosen 2 examples. I'll do it one more time. So 1, 2, 3, 4. I multiplied the inverse by 1, 0. Okay, so what I'm trying to get to here is a pretty funky result that's going to become important soon. Is if we take a matrix and multiply it by its inverse, I will always get the identity matrix. And in fact, if you were to do it the other way around, if I did A to the minus 1 times A, I would also get the inverse. Now, I know previously I've said changing the order of the matrix gives a different value, but for some reason, with this, when you multiply a matrix by its inverse, you always get the identity. This is amazing, and so we can now divide matrices. Yes, well, not in this video, in the next video. And yes, but parting is going to be sweet sorrow, but actually, yeah, this is the end of this video. I'm going to show you how to divide matrices, or more importantly, to use that funky little trick we just did there in the next video to help us solve simultaneous equations and all sorts of stuff. It's been good to see you. Thank you very, very much for watching. If you can, and you haven't already done so, please subscribe to my YouTube channel. It makes life so, so easy for me just to know that people out there are actually watching and that I'm not sitting in here talking to myself. If you can, leave a comment, tell me what you enjoyed about the video. Also greatly appreciated. Share it on TikTok. I couldn't be happier if you could do that for me. All right, otherwise, I look forward to seeing you in another video. Take care, stay safe. See you again.